Welcome to the AI Checkpoints. Today, we're diving deep into a topic that's really fundamentally reshaping how we build large language models, synthetic data. We're going to unpack some truly groundbreaking research here, something that tackles one of the biggest bottlenecks in AI development, what people are calling the data wall.
That's right. And, as we get into this fascinating area, we do want to share an important disclaimer with you. This content, the insights we're sharing, has been meticulously distilled and presented with the help of advanced AI. Our goal here is really to guide you through this pretty complex world of scaling synthetic data, especially now as finding enough high-quality real-world text to train these huge models is getting harder and harder. We'll be focusing quite a bit on a key paper from Dataloggy AI called BeyondWeb, Lessons from Scaling Synthetic Data for Trillion-Scale Pre-Training. All right. It really lays out why generating good synthetic data is so complex, but also, frankly, why it's becoming absolutely essential.
Okay, so let's paint a picture. Imagine you're building this super smart AI. For ages, the plan was basically feed it more internet data, it gets smarter, simple enough. And well, that worked great for a while. But then you hit this sort of invisible barrier, this data wall that the datology AI folks talk about. What exactly is this data wall? Why is it suddenly such a big deal for training LLMs?
Yeah, it's a really fundamental challenge. The data wall pops up because just throwing more and more internet data at these models, well, eventually you hit diminishing returns. Like the BeyondWeb paper points out, that really high-quality, information-dense data just becomes incredibly scarce. So you end up just repeating existing web data. And that doesn't just give you less improvement. It can actually lead to overfitting, right? Where the model just memorizes stuff instead of learning patterns. Plus, you've got other issues, like the style of web data might not match how people actually use these models,
Yeah.
in chat or whatever. And then there are knowledge gaps in areas that aren't well represented online. So all these things together really pushed researchers to think beyond just scraping the web. And that's where synthetic data really comes into play.
Okay, so real world data has its limits, even causes problems. Synthetic data seems like the answer. But I imagine it's not just one monolithic thing, right? The research mentions two main strategies. Can you walk us through those?
Absolutely. There are two main paradigms emerging. The first one they call the generator-driven paradigm. This is where you use really large models, think GPT-4 scale, to generate completely new training data from scratch. Like de novo creation. We've seen this with things like Tiny Stories, Microsoft's Phi models, Cosmopedia. It sounds powerful, right?
Yes, it does.
Generating new knowledge. But it has some significant limitations. For one, it's incredibly expensive, computationally speaking. The generated data can sometimes lack diversity, and it's prone to this thing called model collapse.
Ah, model collapse. That sounds not good. Almost like an AI echo chamber, where it just learns from itself or its generator and maybe loses touch. Is that the idea?
That's a great way to put it, yeah. It's essentially the model inheriting the biases or knowledge limitations of its generator. Over time, this can degrade the quality and diversity of the generated data, trapping it in a kind of knowledge loop. It's a real challenge for that approach.
Okay, so that's one path, the generator-driven one, with some serious hurdles. What's this other approach that seems to be gaining more traction?
Right, that's the source rephrasing paradigm. This is the second approach they detail. Instead of making up new knowledge, this uses smaller, more efficient LLMs to take existing web data and basically rephrase it. But it's not just simple rewording. It's about transforming it into higher quality, more useful formats. Think Q&A pairs, step-by-step instructions, maybe simulated dialogues. Projects like WRAP, which is Web Rephrase Augmented Pre-Training, or NVIDIA's Nematron CC fall into this category. The big advantages here are, well, it's much less dependent on those huge, expensive models. It tends to give you better coverage and diversity because you're starting from the broad base of the web. And honestly, this is rapidly becoming the dominant method. State-of-the-art models announced recently, like Kimi K2, Quinn 2.5, Grok, maybe even GPT-5, are reportedly using a lot of this rephrased data.
Okay, so source rephrasing seems to be where the momentum is. And that brings us right to Dataloggy AI's work, BeyondWeb. How do they take this rephrasing idea and turn it into something, well, so effective? What's their framework actually do?
So BeyondWeb is their specific framework for doing this source rephrasing, but in a very targeted way. The goal is to generate synthetic data that's diverse, relevant, and really information-dense. They do this by combining broad coverage from web data with strategically generated stuff that fills specific gaps, not just topic gaps, but also gaps in, say, instructional style or conversational format. They use a mix of generation strategies, transforming formats, like turning an article into a Q&A, modifying the style, maybe making something sound more like a teacher explaining it, or restructuring content to make it flow better or pack more information in. It's a very intentional, multi-pronged approach, not just a simple rewrite.
That sounds really thought out, promising for sure. But, like always, the real question is, does it work? How does BeyondWeb stack up against other methods when they actually test it? What are the results?
Yeah, the results they report are, well, they're pretty compelling. Quite significant, actually. They break it down into a few key areas. First, it helps models train better. They found that for 8 billion parameter models, BeyondWeb consistently beat other public synthetic datasets. It was something like 5.1 percentage points better than Hugging Face's Cosmopedia and 2.6 points better than NVIDIA's Nematron CC synthetic subset, averaged across a whole battery of benchmarks. That's a solid lead.
Wow, okay. Better performance is huge. What else?
Second, it lets models train faster, significantly faster. They reported up to 7.7 times faster training compared to just using standard open web data like Red Pajama. And even compared to another synthetic dataset, Nematron synthetic, it was 2.7 times faster for those 8B models. Think about the compute savings there. That's massive in the AI world.
7.7 times faster. That's not trivial at all. That really changes the economics. Okay, better and faster. What was the third point?
This one might be the most surprising. It helps you train smaller. They showed a 3 billion parameter model trained on BeyondWeb data actually outperformed a much larger 8 billion parameter model trained for the same amount of time on Cosmopedia data. That really shifts the curve. The whole trade-off between model size, accuracy, and efficiency, it sets a new benchmark.
Yeah.
And these benefits, better, faster, smaller, they saw them consistently across different model sizes, 1B, 3B, and 8B. So it seems pretty robust.
Train smaller. That's the one that really jumps out. For anyone constrained by compute, that's a game changer. But just to play devil's advocate, are there situations where maybe the generator-driven approach still makes more sense, or is this rephrasing method just generally better now?
That's a fair question. Look, universally superior is always tough in tech. The BeyondWeb results are focused on pre-training general-purpose LLMs. You could argue that for really niche areas with almost no existing data to rephrase, or for tasks needing pure, ungrounded creativity, maybe generation still has a unique role. But for the vast majority of LLM pre-training needs right now, given the scale required and the available web data, this kind of intelligent source rephrasing seems to offer huge advantages in efficiency and the final model quality. It's less about replacing all data types and more about dramatically improving the core pre-training mix.
Got it. So the results are impressive, but the paper also stresses that getting this right isn't easy. What did Datology AI actually learn about why it's so hard, and what makes synthetic data truly effective? They boiled it down to 7 key lessons, right?
Exactly. They ran a lot of experiments and distilled it into 7 crucial insights. These are really practical takeaways. The first one, RQ1, is basically that synthetic data is more than just knowledge distillation. You might think, okay, we're just summarizing or condensing existing info. And yeah, simple summarization does help. It increases information density and can get you close to what generator models achieve. But BeyondWeb went significantly beyond that. It outperformed simple summarization, proving that the real gains come from more sophisticated transformations, not just making text denser.
Okay, so it's not just about packing more facts per word. It's about the structure, the style, maybe, which leads into the second lesson.
Precisely. Lesson 2, RQ2, is all about needing thoughtful design to break the data wall. Just naively repeating web data or using LLMs to do simple things like just continuing existing documents, those approaches don't really move the needle much. They don't get you past that data wall. BeyondWeb, because it was intentionally designed with diverse strategies, did break through. It actually outperformed what they call the full data upper bound, meaning it was better than just using all the available real data. This really hammers home that you need a smart strategy. Just generating more stuff isn't enough.
Right, you need intelligence in the synthesis process itself. Okay,
RQ. The quality of the seed data really matters.
Yeah.
Makes sense. Garbage in, rephrased, garbage out. When you're rephrasing, starting with higher quality web documents gives you a bigger boost, even if it means you're repeating some knowledge that's already out there. Quality trumps pure novelty in the source. But importantly, just having high quality input isn't the only thing you need for top-tier synthetic data. It's necessary, but not sufficient.
Okay, start with good stuff. What about the style of the data? That was RQ4, I think.
Yeah, RQ4 looked at distributional style matching. This is interesting. Very little web data, like less than 4%, is naturally conversational. But obviously, chat is a huge use case for LLMs. So they found that if you artificially increase the amount of conversational style data in your training mix, it does help performance on downstream tasks, makes the model better at chatting. But the gains are modest, and they level off pretty quickly, around 20% conversational data. So matching the style helps align the model, but it's not a magic bullet.
So find the right balance there. Don't overdo the chat focus. What about diversity overall?
That's RQ5. Diversity enables scalable learning. This is key. Simpler synthetic data methods might give you good results early in training, but they tend to plateau because the data lacks variety in style and structure. A multifaceted approach like BeyondWeb, which focuses on creating diverse types of synthetic data using different strategies, keeps providing useful learning signals throughout training. It helps prevent overfitting, even when you train for a long time. It's like feeding the AI a balanced diet, basically. Keeps it learning effectively for longer.
A balanced diet for AI. I like that. Okay, moving on to the models actually doing the rephrasing. What did RQ6 find there?
RQ6 showed robustness across rephraser model families. They tested various models for the rephrasing tasks Olmo, Phi, Mistral, Llama 3.1, and found the benefits of the synthetic data held up pretty well, regardless of which family they used. But here's the really interesting bit. How well a model performs on general language benchmarks doesn't necessarily predict how good it will be at generating high-quality synthetic data for training other models. Even smaller, maybe less generally capable models can be really effective rephrasers.
Whoa, okay, that's counterintuitive. You don't need the absolute best model to do the rephrasing. That must have implications for cost, right? Which leads into the last lesson.
Exactly, that flows right into
Yeah.
RQ7. Rephraser size matters, but it saturates. They saw big gains going from a 1 billion parameter rephraser to a 3 billion parameter. One performance jumped about 1.5 percentage points, but going from 3B up to 8B, the gain was much smaller, only about zero point 0.4 points. It starts to level off. So the takeaway is that relatively small LLMs, maybe around that 3D size, hit a sweet spot. They can be very effective rephrasers, making the whole synthetic data generation process much more scalable and cost-effective. Bigger isn't always better for the specific job.
That's fascinating, a Goldilocks zone for rephraser models. Okay, so we've gone through these 7 detailed lessons. If you had to synthesize all of that, what's the big picture message here? What's the overarching takeaway from Datology AI's work?
Well, the core message, and they state this pretty clearly, is that generating really high-quality synthetic data for pre-training is genuinely hard. There's no single magic trick. Getting great results means you have to carefully balance and optimize a whole bunch of different factors together. But, and this is the crucial part, their work with BeyondWeb shows that if you approach it thoughtfully, scientifically, using this kind of source rephrasing, these challenges can be overcome. And the payoff is substantially better models. They kind of boil it down to 3 guiding principles. Start with high-quality sources, even if it means less novelty. Make sure your synthetic data style aligns with how the final model will actually be used. And, critically, maintain diversity in how you generate that data.
So it really drives home that it's not just about data volume anymore. It's about intelligent, strategic data creation. Quality and diversity, carefully engineered. Where does this leave us then? What's next? What future directions does the Datology AI team see based on this research?
Yeah, they point to several exciting avenues in the paper. One big one is better understanding the scaling laws specifically for synthetic data. How does it behave differently from real data, especially regarding repetition? That's still an open question. Another is pushing further on democratizing synthetic data generation. Can we use even smaller, more extensible models as effective rephrasers? That would lower the barrier to entry significantly. Then there's the potential for using synthetic data generation for AI alignment. Can we build safety and alignment with human values right into the pre-training data itself, rather than just trying to tack it on afterwards? That's a really powerful idea. And finally, expanding these techniques beyond just web text. Can we apply similar rephrasing and generation strategies to other domains, scientific data, medical records, code, and other modalities, maybe even images or audio? That can unlock progress in many different fields.
It really feels like synthetic data is moving from a niche technique to a central pillar of AI development. It's offering this crucial pathway to get past the limitations of real-world data to break through that data wall. This deep dive really underscores that it's not just about quantity anymore, is it? It's about the quality, the diversity, the intelligence baked into the data itself. Though it does make you wonder, if we get really good at teaching AI by rephrasing what we already know, how do we ensure it can still make truly novel leaps? That's maybe a question for another day.
Absolutely, it's a fascinating tension. But right now, the ability to intelligently craft and scale data, as shown by work like BeyondWeb, is clearly paving the way for the next generation of AI. It turns a major challenge into a real opportunity.
Well, if you found this deep dive into synthetic data and the BeyondWeb research as interesting as we did, definitely hit that like button and subscribe if you enjoy this kind of content. We'll see you next time on the AI Checkpoints.